Okay, well, thank you so much to the organizers of the NoConName 2020, this magic year that we are all living, and it feels like a Black Mirror episode. But thank you for the organizers for inviting me to be with you all today and do a little bit of a workshop about the fascinating world of detection infrastructure, and in this case, osquery and OS control. So the title of the presentation is scaling osquery with OS control. A brief introduction about myself. My name is Javier Marcos. I've been working in security for quite a bit of time now. Before even it was called cybersecurity. Now everyone is talking about cybersecurity. So I've been in the game way before it was called that. And currently I work as a staff security engineer for an investing group called 100X. And I've been working on different tech companies such as IBM, Facebook, Uber, or Airbnb, where I mostly have developed and implemented detection infrastructure, production monitoring systems, to not just got into details, basically to how to monitor thousands or millions of machines with being very efficient with the resources. And currently, I provide security services for cryptocurrency exchange, and also I'm the founder of my consulting company, GMPSec. So if you have any questions about detection infrastructure or anything related, just give me a shout. The agenda for the presentation or the workshop, it's I'm going to go through a couple of things. So the first thing I want to mention is I'm going to do a quick overview of osquery. What is the tool? I'm not going to go into a lot of details of osquery, but I'm going to be kind of like explaining a little bit what it does and how the configuration it's done. Sorry, I'm gonna put a timer here so I know how long I've been speaking. So I'm gonna go through a quick overview of osquery. If you want to go into the details of osquery, I have some other workshops on the topic, and if you look them up on YouTube or in my GitHub, probably you'll see them. So if you really need to catch up on osquery, I suggest to go that, because I won't be going into many details about osquery itself, because I want to focus at the osquery remote API, which is the thing that we are going to be using for building a TLS endpoint, which is the part of the infrastructure that we collect the logs of osquery, and they will be collecting logs, distributing configuration, and doing other forms of fleet management. Then I'm going to be talking a little bit about oscontrol. That is the TLS endpoint that I wrote and has been deployed in several companies. And then to end the session, I will go through conclusions and some lessons learned. To start with the quick overview of osquery. osquery was a tool that was developed originally by Facebook back in 2015. That's when it was created and open source. And I was part of the original engineering team that built the tool and developed and open sourced it. So currently, osquery, it has a huge community behind it. It's used by thousands of companies. There is businesses that have been built on top of osquery, and it has grew to be almost the standard way of host instrumentation, or the cornerstone for detection infrastructure. But originally, we were just 3 engineers working to get a solution for the problem that we had at the time at Facebook, which was how to monitor hundreds of thousands of nodes with a very efficient and with a small fingerprint tool. And that is exactly what we built. So osquery provides an abstraction in the form of SQL to see what's happening in the operative system. And the first caveat I want to, or the first thing that I want to point out about osquery is there is multiple components of osquery. The first one I want to mention is the osquery I, or the CLI of osquery. That is basically when you run osquery I in your host or the machine that you have osquery installed, you are going to see the command line interface, the terminal for osquery, which you are going to be able to see the tables and run queries. And this is what extracts information from a single host from a first user perspective. So the results, you're going to see them immediately. The second thing I want to point out about osquery in terms of single host is the osquery or the osquery daemon, which is what it will run in the background in the system, extracting information and send it somewhere else. So when you have an operative system with its users, services, the data associated with it, then you have osquery running on top of that operative system information, and osquery actually extracts that natively. It doesn't really wraps the way of work. It doesn't wrap within system calls or anything like that. It is actually extracts information natively. And then the daemon osquery it's configured based on a number of flags and configuration, whether if it's remote or local, and it generates logs or it generates some information, some data for that is extracted from that operative system that we have mentioned. Then you need to first distribute the configuration from a centralized place, and then collect those logs that are generated, also that are reported to this centralized management. And on top of that, that is where you build your intrusion detection use cases, which, for example, in this case is like, what do you want to use osquery for? Do you want to just extract information about the state of the machine, or you want to query about policies, multiple different policies that you want to apply in the hosts, or you want to monitor the users that you are going to be like they're logging in and out on systems, or do you want to query the processes that are running, the connections that are established, or you want to monitor for threats in the machines, like you want to see when a specific hash file lands on a system. There is obviously, depending on your strategy for incident response, there is multiple ways to execute these intrusion detection use cases, and this is basically a very high level approach to this problem, and with like having osquery the daemon for osquery as a core of this environment. And again, this is for a single host. But what happens when we run osquery for a number of hosts? Like we have a number of machines that are running these, and you'll have pretty much the same thing, but for multiple hosts. So the same operative system that the osquery sits on top, that receives a configuration, that generates logs, and then those logs are collected, and then the intrusion detection use cases sit on top of that. And those can be, of course, different for each machine, depending if it's a production environment, if it's a corporate environment. So based on all that, this would be like the same high level abstraction on top of this problem. We've mentioned the osquery logging, or the logs extracted from the host, which is in our case, how do they look like, the logs that osquery extracts from a system? So, well, you have you have to do a distinction here between local logging and remote logging. So the local logging are going to be those logs that will be dumped into local files in the system where osquery runs. And those are just like standard log files that are locally in the system. How to collect those? Well, if you want to collect those to a third-party remote system, you'll have to use like forwarders, or at least is in the industry, usually you use forwarders such as like Logstash, Splunk Forwarder, to basically collect those logs. And when there is new logs generated, then you extract them and then you send them away. However, osquery also allows to to do remote logging in the current configuration of osquery, or the current state of the project, allows to do Kinesis, Kafka, Splunk, and the TLS endpoint, which is the use case that we are going to be focusing on. Basically, the concept is that when the log is generated, osquery does send them using a secure protocol to this remote system, whether it's Kafka, Splunk, or TLS endpoint. The other component of the osquery daemon was the configuration that is received to be able to do what is meant to. Again, we have to do a distinction. We have to discuss local configuration and the remote configuration. Local configuration would be a configuration file or a JSON file that is local to the system where osquery runs. And usually the standard in the industry is that those configuration files, you have them, you manage them with asset management platforms, like, for example, could be Chef, Puppet, Jump, or Ansible, for example. Any other MDM as well, could be like AirWatch, or I don't know. Like there's multiple solutions out there to just basically make sure that those configurations are updated locally. But again, the remote configuration in this case, osquery allows to be configured remotely using the TLS endpoint, which is the use case that we're going to be focusing on. We've discussed a little bit some details about osquery, how it works for single host with osquery I and the daemon osquery D. We have discussed a little bit how the logging and the configuration applies to this tool, and now we're going to be focusing on the osquery remote API, what it makes possible to implement things like a TLS endpoint solution. Here, this is another high-level diagram of what it means to utilize the osquery remote API. So here you can see the different hosts that you might have running osquery. Like osquery is a tool that supports multiple deployments or systems like Windows, Linux, OS X, and FreeBSD. There is also some ports out there for IRM and some other architectures, but excuse me. All those machines are going to be running osquery, and then the logs of those systems are going to be traveling on the network through the internet, and then in order to reach the TLS endpoint and be stored, and the configuration of those nodes is going to be getting to them following the same secure communication protocol or like through the TLS endpoint. And there is one thing to mention here. Since the very beginning of the development of osquery, we wanted to have we wanted to make osquery to be able to communicate with remote systems only using TLS. Many other agents or endpoint monitoring solutions, they allow to do unsecure protocols such as TCP, UDP, or HTTP. But osquery has been designed to only support like TLS communication. So the TLS endpoint will have to implement HTTPS. Obviously, when you are proficient on building your osquery packages, there is certain ways to kind of like build a development package that can be utilized HTTP. But the main focus of their design and production packages is that only will use TLS. Or what we're seeing in this diagram is that the communications, the data leaves the osquery hosts and go through the internet and ends to the TLS endpoint. But how that happens? How is the protocol or the osquery remote API looks like in order to achieve this? Excuse me, I'm talking a lot, so I need to clear my throat. So there is a number of number of endpoints that osquery need to reach out in order to be able to do its functions as for the remote API. They are the enroll endpoint, that is the system in the handler for the TLS endpoint that will actually process enrolling of new nodes. And there is the configuration handler, which is what will actually, as osquery will reach out to in order to retrieve the new configuration to be applied. Then the log handler, which is going to be the endpoint where osquery will utilize in order to logs from the system. And finally, you have some other endpoints which are for either on-demand queries or file carving. There are some others that are undocumented, but I would encourage everyone to go to the source code of osquery to read for undocumented features, because those are actually where there is quite a little bit of complexity in those, and allow you to to implement quite complex functionality. I'm going to be mentioning a couple of them. Right. So we have discussed which are the handlers or the endpoints that osquery will reach to in order to implement the remote API. So, for example, for the enroll one, which is the one that osquery will use to register itself in the TLS endpoint, this is the format of this of the protocol. So that's going to be a post request to the endpoint of enrolling in the TLS endpoint, and it will have to contain the fields in the JSON for the enroll secret for each node, host identifier, excuse me. So host identifier, and then within that request, there is a number of host details that can be appended to the remote to the enroll request. Like, for example, the OS version, or some information about osquery, some information about the system. Those are actual tables of osquery. So that is very handy when the request is received in the server, because then it can be used for identify or for metrics or for a bunch of like extracting metadata about the enrolling request and whatnot. The response from the server is once if the received secret is correct, then the TLS endpoint will generate a unique node key, and that is from that point, osquery will use to identify itself to this TLS endpoint. So if that node key doesn't change, then the TLS endpoint will consider that node to be valid enrolled, and then it's going to continue to respond to the request. And then that way, osquery doesn't have to append the secret to each of the requests. However, there is a way to configure osquery to actually force that secret to be appended to all the requests. But anyway, yeah, and then the field of node invalid is basically what it will force. If you want to force the enrollment of a host, then you will have to set this node invalid to true, and then the node will attempt to enroll again. The configuration endpoint, it will be just the node key that we have discussed in the enrolling process. It's just basically a request of osquery reaching out to the TLS endpoint saying, hey, do you have a configuration for me? And it will have to provide the unique node key in order to be able to be identified. And then the response of this request is going to be the schedule of the queries that the TLS endpoint wants osquery to run with its intervals. And again, if in the configuration process, the TLS endpoint would like the node to force the enrollment again, it will have to set the node invalid to true. So yeah, this is this field of a schedule. It would be the same as if you look up the configuration, the local configuration of osquery. That would be like the schedule field of the JSON file. Okay, have we discussed enrollment configuration? Now we are going to we see what is the format of the logs request. So these are the fields that whenever osquery has some results or status logs to be sent to the TLS endpoint, then this is the format of the request. So again, same node key identifier that it was retrieved at enrollment. The type of log that we are going to be sending, it could be status or result, depending of what type of information osquery wants to store, and then the data of the actual log. So the difference between result of status logs is result is the actual result of a scheduled query. So when you ask osquery to run a query, the actual results of that query. A status is more like extracting like the internal state of osquery itself, and then notifying that to the TLS endpoint. So if something happens or the mode of operation of osquery is set to verbose, then all that information is being sent to the TLS endpoint using this log type. And this is the response from the TLS endpoint. Again, using the node invalid field for JSON, with setting these to true will force the re-enrollment, same as for the configuration and for the enrolling endpoint. Okay, so we've discussed enrollment, logging, configuration, and then we are now going to see the other, or it's not optional. Well, it could be optional, but it's actually shows a lot. What is the capabilities of osquery? What are the capabilities in terms of almost real-time queries, file carving, and whatnot? So in this case, this is the on-demand queries, the read function. Read function means the request that osquery will be sending to the TLS endpoint to basically ask the question, do you have any queries for me? So this will be used in the TLS endpoint as a checking or a beacon from osquery to say, hey, do you have any queries? And only we'll have to have a node key, the node key that was retrieved in enrollment and is used for the other endpoints as well. It will just be a post request with this format. The response for this request, it would have as JSON, it will have the key queries, and that's gonna be the list of the queries that the TLS endpoint is requesting the client to execute. Those are the queries. Those are not the scheduled queries, which are the ones that run the number of interval in seconds. But this is actually going to be running one time only, every time that they are sent back from the server. And again, the same node invalid field, which for setting it to true, it will force the client to be re-enrolled and then generating a new node key. So those were the on-demand queries for read. But what happens when the osquery client sends a request to the server and saying, hey, do you have any queries for me? And then the server replies with a list of queries. Like it replies, for example, in this case, the response is going to be in this format. So what happens then? Then what happens is that you have to implement another handler for collecting those logs, for collecting the results of the on-demand queries that you just instructed the osquery client to run. So in this case, we are going to be using the format of the post request in JSON. Going to be using again the same node key that is set on enrollment. The queries, we are going to be using the same key for the JSON, but we are going to be identifying each of the queries that we're seeing in the on-demand queries read, and in that field we are going to be the data, the result of those queries is going to be appended. And there is something else, which is the statuses. Statuses field in JSON is going to be providing what is the actual status result of the query, the execution of the query. So if it's the status is 0, means that the query runs successfully. If it's not 0, means that something happened through an error, or maybe the table isn't there, and that information will later appear in the status logs from osquery. So that is the type of information that status logs are going to be reporting. Saying, for example, if you are attempting to execute an on-demand query on a table that doesn't exist, that entry will appear in the status logs. The response is simple as well. So that is the same case as on other endpoints. Just the node invalid set to false to basically instruct the osquery client and nothing happened, or if it's true, then it will just force the re-enrollment. The idea of the enrolling configuration log, on-demand read, on-demand write, and all that is basically having a remote API that is both strong and simple, because simplicity is the key component of osquery in terms of, I mean, I'm not saying that the tool is simple under the hood, but it's designed to leave a very small fingerprint in the system, so it will run very efficiently. And with efficiently means that it will utilize very small amount of RAM. It won't force the CPU to spike too often. So that way it will have a very minimal impact to the system where it's running. So that's kind of like the idea, that whole concept, that basically it's expanded across every aspect of osquery. It tried to just simplicity yet strength. It's kind of like transpired to every aspect of the osquery architecture. So now we've discussed the concepts, or the caveats of the remote API for osquery, and how can we just actually utilize those endpoints from the client perspective? How do we configure the client with to use these? So these are the flags of the endpoints that I just described. How to just basically set them. Oh, excuse me. So the enroll, it will use enroll TLS endpoint. I mean, the details of this are in the wiki of osquery, which is a tremendous wiki. Has all the information very well put together. And if you want to learn more about osquery, I would encourage you to start with that, because it actually covers very well how to configure the client locally and remotely. But to just do a quick overview on those flags and how to configure the client, then this slide is actually the information you want, which is the TLS endpoint. What is the hostname of the TLS endpoint? Same for the logging. What is the hostname and what's the period? How often do you want osquery to actually reach to that endpoint? Same for configuration, and the same for the queries for both read and write. All right, now that we know a little bit more about what osquery does, how it runs in a single host, and both from the CLI and the daemon perspective, how to utilize the remote API, what is actually the caveats of the remote API for osquery. Now we can cover the other side of osquery using osquery for a remote endpoint, which is actually discussing a little bit the TLS endpoint, building the TLS endpoint. And one thing I want to actually focus on in how to scale a TLS endpoint, because building a highly available system and expected to be highly scalable, it's not just putting it together and then hoping that you will always be able to throw it in a bigger instance. For example, if something goes wrong and you don't, it's starting to consume a lot of resources, then you might think that you can migrate it to a bigger instance, but whether if you are using AWS, bare metal, or any DPS or something like that. But the key is to understand, when you have a performance issue, what is the root issue there? What is what you should be focusing on? Because always there is always a bottleneck somewhere, and those are the things that I really like to look at and like be able to find when something becomes a problem, and how to actually make that disappear, basically just using good engineering practices. So we've been discussing in the remote API of osquery that we are going to be building a handler for the enroll, handler to collecting logs, handler to actually distribute the configuration to osquery clients, and then handlers for other extra things, such as on-demand queries for both read and write, file carving, which is a specific type of on-demand queries. But now that we've discussed this in terms of from the client perspective, how can we let's discuss this from the server perspective. So in our case, let's say that with the flags that we've discussed before, now we have one osquery client, and we have a TLS endpoint, and then the internet. The information flows from the osquery client through the internet, and it goes bidirectionally to the TLS endpoint using TLS communication or secure communications. The client enrolls, then the configuration is sent back to the client, and then logs are submitted to the TLS endpoint, on-demand queries, file carving, everything. So this would be a very, very high, like a high, the way of like the high, the way to describe this problem of TLS endpoint from a high level perspective. So what happens when you have not one client, but a number of clients? Like you have thousands of machines running osquery. How this impact how strong and scalable your TLS endpoint is going to be? Obviously, all that information is going to be multiplied by the number of nodes, and your TLS endpoint undoubtedly is going to be it will have to handle that load accordingly. And sometimes you're going to have scalability issues. You will have to be able to handle those requests in a better way in order to not let your infrastructure to be damaged or to just go down. So for the let's discuss a little bit of how would we scale a TLS endpoint. Like for example, we are going to go to the basic use case of having one client, and let's think about like having that osquery client, and then let's presume that we are going to be configuring it to say, okay, I want that osquery client to be configured every 60 seconds, and I want the distributed interval to be to reach to the server every 60 seconds as well, and I want the logs to be sent to the TLS endpoint every 60 seconds as well. So this basically is going to be one request every 30 seconds per each of those. So that means that we have three requests per minute, or 3 requests per 60 seconds. So this is nothing very special. This is something that it's kind of okay. It's not rocket science. It doesn't need to blow anyone's mind. But what happens? Like usually, these very easy to work with figures are not always the case. So the moment you start working with like hundreds of thousands nodes, you're going to have like different environments with the different refresh intervals. So how does it work in those cases? Like let's say that we have an n number of nodes, again, of osquery nodes that are configured with different values. In this case, the refresh of configuration, it's done every 300 seconds. The distributed interval it happens every 100 seconds, and then the logs are retrieved every 600 seconds, every 10 minutes. So that is when it gets tricky, because now you have to basically work out going to be, or do I have to expect in the server side? Because like ultimately, if you're building a service, you want to know your ultimate task as an infrastructure engineer is how many requests per second can I handle? Because that is kind of the number that you want to know whether if you're going to be in trouble if you don't scale up, or you are totally fine and you are going to be okay based on estimations, of course. In this case, I show here, like for example, doing for example the intervals every 100 seconds. So let's start T0. It goes right here, and then okay, first 100 seconds a query happens. The next time that 100 seconds go by, another query happens. Boom, we hit 300. 300 seconds here, another query happens. Same for 400, 500, and when we hit 600, something else happens. But at this point, we are going to be running one query every 100 seconds, right? But as we saw in the values for the intervals, every 300 seconds we are going to have a config request, and so in this case it happens at the number 300 and at the number 600. So every 5 minutes, every 10 minutes, you're going to see these. And because the interval for logs is it's 600, here you can see that as well is going to happen at 600. So T0 happens, 100 seconds go pass by, one query. Another 100 seconds go, another query. So at this point, we have two requests here. 300 happens, or another 100 seconds go by, and then we got another query and one config request. So in this case, like one request, 2, 3, 4. And then we have to continue to work out these. So how can we do this without having to do these silly diagrams for all the environments? Well, it's basically like if you calculate you do the sum of the highest interval divided by each interval, then in this case we're going to have in the environment that we saw, we're going to have 9 requests per second based on for example in our case an n number of machines. So like for example, let's see, for 1,000 nodes, in this case, yeah, like we presume that we have 1,000 nodes. Let's say that we are going to have 9 requests per second based on that configuration, and then for 1,000 nodes you scale up and you're going to have 100 requests per second. So that's going to help you to build your infrastructure very well, because then now you have a specific number that you can calculate and say, okay, well, can my infrastructure take these? Or these are how many more nodes can I add to the system in order to continue to expand my infrastructure? So this is one of the things that I wanted to cover in this talk, how to actually work out these numbers to be able to scale your infrastructure. What happens with this approach? Okay, this approach it takes into consideration what is in a perfect world. Let's put it that way. It doesn't really takes into consideration the number of requests you're going to have at T0, which is then rolling. Those number of requests are going to be creating peaks. So because if you enroll 500 nodes at the same time, and if your query exactly at the same time, you're going to have 500 requests immediately. So what happens also with query writes? What happens with file carving, which is a type of on-demand query read? What happens with accelerated mode? Accelerated mode is an undocumented way of osquery, which basically reduces the interval for on-demand queries for a limited period of time, which basically because it allows the TLS server to behave as a command line interface through the TLS endpoint. But it's if you really want to learn more about accelerated mode, I would suggest you to look at the wiki of osquery to see what it does. And there is one important thing, which is all those intervals aren't splayed, because by default osquery does splay it's the intervals of the queries, but it does not splay the intervals for the TLS endpoint. So if you're going to be like, it happens very often that your infrastructure is built using Chef. If Chef uses the same timestamp to build all your infrastructure, and it runs at the same time because it's not like sharded or it's not displayed, then you're going to have like a specific moment when a number of your machines are going to be running all these requests at the same time. So you will have to take that into consideration for your infrastructure. But once you know about it, you can just build your tools around it. The problem is when you don't take this into consideration or you don't expect these problems, then yes, you're going to have definitely some scalability issues and your infrastructure is going to suffer. All right. Well, we've discussed, the osquery, how to run it in a single host for both the CLI and the daemon perspective. We've discussed a little bit the remote API that allow us to build a TLS endpoint. We've discussed how to build a TLS endpoint and how to scale a TLS endpoint. Now let's kind of like let's focus at an example of a TLS endpoint that has been built and open sourced. To basically provide the solution for this problem. I mean, in this case, this is OS control. It's a TLS endpoint for osquery. The idea behind OS control was to build something that was very fast, very efficient, following the same idea in building osquery in the first place. And it basically tries to make those scalability issues easier for the system administration or the people that handles the infrastructure, the security infrastructure for a team or a company. The idea, I mean, this is the diagram of the architecture for OS control. Here, like we can see that here we have the client that we discussed about, where it's going to be generating status logs, results logs, and those are going to be sent to the TLS endpoint, and it will be received and confirmed. That it received the configuration from the TLS endpoint. That traffic will go through the internet, and the idea is that it will the TLS termination layer or Nginx, which can also act as a load balancer for modern orchestration architectures such as like Kubernetes on things like that. Then usually the ingress layer acts as the Nginx termination. So that's where the TLS connections are terminated, and then that's the traffic is redirected to the specific pod. But in our case, we can just deploy these using standard virtual machines, Docker, or just Linux servers. And the part of the architecture that handles all the load is OS control TLS, which is what is going to be receiving all the data and passing on all the configuration to the clients. So that's going to be, this component is going to be handling all that. OS control TLS will use the backend or the database in this case to pass information back and forth to other components of the architecture that like could be the CLI of OS control or the admin or the API. So those are going to be the components used by the operator of OS control to basically handle or manage all the clients that are enrolled in OS control. And most likely are going to be in some sort of DMZ. They're going to be located in some sort of like secure protected area or DMZ or something like that. So access through a VPN, usually that's the case. And then all these systems are going to be generating metrics, which are very helpful for monitoring and managing your infrastructure. So if you want to find out more a little bit, go to oscontrol.net or in GitHub, and then that's where kind of like all this information is fully documented and the code is as well. Okay, so we discussed a little bit the architecture of OS control. OS control can be used for monitoring osquery assets. It collects and processes the status and results logs, which can be stored locally in OS control, or they can be sent to another system such as, I don't know, Kafka, or Splunk, Elastic, S3 buckets. Anything that you might want to build behind OS control is ultimately up to you. The configuration for osquery nodes is distributed pretty fast and running on-demand queries on those nodes, and as well extracting file or directories using file carbs. So those are the pillars of OS control. Why it was built in the first place. These are kind of like the points of doing that. And I'm going to be showing you a little bit of how OS control looks like from my perspective. So let's see. I think I forgot. Yeah. All right, let's build it. Actually, let's build OS control here. That's going to be I'm using a master branch of GitHub. So if you go to OS control and the GitHub, this is basically what I'm using to build this demo. And then at the same time, I'm going to be also building some clients. So please, yeah, these are the internal network that I'm going to be building for this this demo. Let's build this all, because then we can show everything at once. This is building. OS control should take a few minutes to build. This is building here. Let's wait for this. And in the meantime, let's discuss a little bit. Where is the presentation? Here. Yeah. Okay. Actually, yeah. I want to be while OS control is building. One thing I want to actually discuss or basically talk a little bit about is how originally OS control admin was just one component. So the addition of the OS control API was done a couple of months ago, where I saw there was a need for an automated way to basically manage the information that the OS control TLS handles to the clients. So I was using that with OS control admin, but then there was a need to have some sort of automation that is not, it doesn't have to be web necessarily. So it has something that can be automated very well. And at the same time, some other tools can be built on top of them. So for example, in the case of OS control API, there is a colleague of mine has built something called GoQuery, and it uses the OS control API, which is it's basically an implementation of a command line interface on top of the TLS endpoint. So it allows you to query clients, similar to what the OS control CLI, but the OS control CLI only allows to run that from the actual server because it uses the backend. But ultimately, OS control CLI will be using the API. So yeah, if you actually look up OS control API, I wrote an article a couple of months ago about how important API components are for security products, because a proper API is going to make the big difference between between a product that can be used or something that can be used within a security engineering team. Because like a vendor can be having a proper UI or having a way of interfacing with a solution, but ultimately I want an API to kind of build my own automation, like the automation that I want to run myself actually. All right, let's take a look at staking, generating this. This is running this. Okay, this is running here. Let's get into this box. CentOS machine. This is Debian. Let's gonna get into this box here. Let's build this one. Let's build this one too. And the last one. We're gonna have all these machines built. Okay, so this is all done. CentOS is ready. Debian is ready. This one is building. This one is building. Where are we in OS control? Still generating the keys for OS control for the TLS termination. Cool. So I think we could go into. Let's see. Yeah, let's go do this. Right here, this one. All right. Yeah, if you look at the actual development, I try to keep it as active as possible. Obviously, there is the there's the daily job that is not doing this. But yeah, it's if you are interested on OS control, definitely check out the GitHub repo. And if you need something, creating an issue usually helps me to kind of like have an understanding of what people need. And there is an actual Slack for osquery, and I have those control channel there. So that's definitely a way to communicate with me directly in terms of OS control of whatever other needs, other things you might need. All right, let's see. This is building other systems. Okay, this is the backend. This is ready. Yeah, CentOS is ready. The game is ready. This is ready too. Put in there and SSH. Okay. Okay, so these machines are already, they are created. This is finishing building. One thing that I want to kind of like show, it's like how I don't know how. One thing I want to show is like I want to go through the basic things that you might actually encounter when you use source control for the first time. Like cover it, what is the enrolled clients, or how do I actually use the settings? And I should probably like do a better job documenting all this. But like for example, this demo is actually the first time that I'm doing a full end-to-end demo of run control and then changing and touching some of the settings for the server. So this is going to be good material to share for people that want to start using OS control in their environment. I think that should do it. Influx, yeah. We're building metrics. This should be ready very soon. Okay. I don't think, yeah, this is basically the way I'm building this. I'm using the master, I'm using the local environment for using Vagrant virtual machines. You can also use Docker to build this. So Docker will also run a fully working environment. But in this case, I like using Vagrant machines because the network is a bit, I don't know, it's like I'm old school like that. I like using Vagrant machines, and it's just, I don't know. I like doing that. Okay, this is ready. Almost. Come on. This is getting there. I think this is enrolling. I am enrolling the server to. Yeah, I'm rolling itself because by default, OS control creates the. By default, OS control creates the dev environment, and it actually enrolls. If you do Vagrant app, you enroll the OS control enrolls itself in the like OS control will actually install osquery on the server and will it enroll itself. So you will be able to see it in the list of nodes. And this is the way it's done like that is because then you can start testing right away. Let's see one thing. Okay, this is going to be, oh yeah. One thing that I actually go through in the, yeah. Right. One thing I go through in the actual documentation of OS control is that, okay, the deployment that I am actually covering here is what is the deployment using Vagrant. I have if you have used Vagrant before, I have a Vagrant file in the actual repo, and by just running Vagrant up, it gets it ready. But if you actually read the Vagrant file, you're going to see what to run, and then here I have like a little bit of I have captured the actual deployment. Okay, I think it should be ready. Yeah, creating the admin user. We are almost about to finish. Now it's going to be enrolling itself. Yeah, this is now the installation of osquery in itself, and it's going to be enrolled in the in itself. So the things I want to do right now in the in oscontrol, the things I want to show is what are the different settings and how to use those for when you want to create different environments. The environments for oscontrol is basically the when you want to split like say, okay, I have production machines and I have corporate and I have test, and those actually logical abstractions of machines. Those things are what the actual environment wants to cover. So there you go. So now we have oscontrol ready. It took actually 9 minutes. That's a long time. I should know what was taking so long. Probably it's my internet here. Anyway, okay. So this is ready. Now that's yeah. So we have 5 CPS, and the port that is configured is 8443. All right, Chrome is, there you go. So by default, the user is admin and admin. You can actually configure that to have that auto-generated, so it's not that insecure. It's actually get a bit bigger, yeah. Okay, so this is how you see, like this is how oscontrol looks like, or like initially when you first create, but when you try to run the local dev environment. So like you said, like I said before, these are the dev environment. This is actually the oscontrol server itself that it enrolls itself, and it's actually enrolling. So the first thing we're gonna do is let's move this somewhere else here. The first thing I want to do is let's go and create an environment. So for our demo, so let's see. Okay, let's create an environment. So let's gonna call it NCN 2020. Host name is the same IP that we deployed. 5. The type is for osquery. It's something that I eventually will use in the future, but not yet. And this is just font awesome icons. So let's put a lock here. So we create the environment. Now we have this environment. It has been created here. Now, one thing that we need to do is, and then let's do it immediately, which is by default, the dev environment has the intervals for the server to refresh the settings and all that. Let's actually change those so we can see things happening way more fast. So I won't bore you guys too much. TLS settings. The first environments, let's do it every 20 seconds. 20, yeah. And these 20 as well. Let's not touch that. Yeah, that's the configuration. And now we are going to do one thing, which is this environment. It was created with a certificate that was it was created in the deploy process. So that certificate is just self-signed. It what allows osquery to talk to the server, because osquery only establishes TLS communications. So in order to do that, we need to we need to add that certificate. Otherwise, the clients won't be able to enroll. So here's the secret. The secret is generated. The flags are generated, and we are going to be putting the same certificate of the other one that it's created automatically. We'll upload it. There you go. So now we have, we have the certificate. The secret is that this is the actual one-liner for enrolling machines. So by default, it expires, and you can extend it for 24 hours. So we are going to be actually using this for enrolling the clients. But before doing that, let's change actually the configuration interval so we can actually see happenings, see thing happenings way faster. So the configuration change, let's do it 20 seconds. Login interval, let's see it with 30 seconds. And the query interval, 21 seconds. Why not? All right. Intervals are saved. Actually, let's copy this schedule here. It's just a standard query. I'm going to show you later how actually that changes. But let's put it here. There you go. Okay, now we have an actual query, and then it's gonna run this every 18 seconds. Well, every 20 seconds. 22 seconds. So we have one actually query, 21 seconds. Yes. Validation saved. So now that we have these all saved, we can just go and copy the enrolling. So right now we have there is no nodes. There's nothing enrolled in this environment, and we are going to be enrolling all the machines that we just created in this environment. So okay, this is CentOS. We run that. Oh, by the way, the one-liner does install osquery if it isn't installed. So now it has detected that the query is not installed and is installing it. And it's basically just taking care of all the setting the configuration for the secret, the flags, and the certificate. Is keeping that installed and then reloading osquery so that can be used. So one thing is that we see this here. Okay, this machine got enrolled, and now we're going to basically do the same for all the other machines. So let's just do that. This is CentOS, that is enrolled. Debian, Ubuntu 14, this is Ubuntu 18, and Ubuntu 20. So basically it's doing the same thing, installing the dev for osquery, and we're gonna see these guys appear in the, now it's fighting for the bandwidth, I guess. Well, okay. So we're gonna start seeing these all these machines appear here. That we are going to, we saw them all. So we have the CentOS 7 that we enrolled, the Debian 9, Ubuntu 14, and Ubuntu 20 probably will appear soon. Yeah, there you go. CentOS, Ubuntu, there you go. All of them are here. So these are the machines that we just enrolled and we just created locally. And we have set up or configured the settings for those. We've added the new environment, the copied certificate, and now we have changed the settings so we can see things happening way faster. Got the queries in the schedule, so we're actually going to see some logs flowing. And in that case, okay, let's actually show you that because that's interesting to see. So there you go. You see, these status messages are basically internal status system messages that osquery generates, and you can actually see them from oscontrol. So these are the same as if you go to the osquery locally, and then you check out what is generated via syslog. So you can just see it here, and then there hasn't been anything generated. So these machines got enrolled 43 seconds ago. Last status was 13 seconds ago. Result, and then the configuration was just refreshed 3 seconds ago. These are all the information for the machine, and the results logs are. This is the actual uptime that we are querying from that from the configuration right here. So, for example, if we add here something else, let's see. Let's actually, I'm gonna show you the on-demand queries first, and then I can probably show you how it actually looks like when you want to see the when you want to add something to the schedule. So okay, now we have all these machines added, and then let's see. Okay, now we have let's say that we want to run an on-demand query. Let's say, okay, we're going to run this in the Ubuntu 18, right? So we're going to be, okay, I want to actually get some information about the kernel. So let's do kernel info for this machine. So let's see, okay, I want to select start from kernel info in this box. So, okay, we just run this. The creator is admin because that's the default user that we created. The creation has been just now. The status is active. This is the progress, and this is if everything goes well, and if there is an error. Because the on-demand queries is like 20-something seconds, it will take a little bit. There you go. It just run, and then here we can actually see it run. that the type of target that we specified, we selected by the host name, and this is the machine that we selected. It did run, and this is the result that we actually extracted from machine. So that's actually the table kernel info from that host. And let's say, okay, what if we say, okay, this is actually very helpful. How do I extract this from all the machines at the same time? Very, very simple. So the only thing we have to do is we go to the configuration and we say, okay, it's something, which is, in this case, we're going to do, okay, let's do kernel NCN, because we want to have that as the alias. So we do that, and we do this. It's an actual, it checks for the validity of the JSON and the query. We specify here what is the actual query that we want. Select start from kernel info, and then interval is basically how often that's gonna be running. So we'd say, all right, we want to run this every 20 seconds. Very similar. So the JSON is valid. This is all good. So we are going to be extracting this information from all the machines that we have enrolled. So now, if we actually go to these 20 of these hosts, it's let's see. Okay, they just checked in. Like, let's see. Okay, we run these. If you go to the all queries that run, we did run this in the Ubuntu 18.04, right? But if, like, let's see, okay, which are the machines that I want to see? Like, let's see if actually that ran in all the machines. So results logs, there you go. This query is scheduled, and it will run and will report it because the name is kernel NCN, and then it's actually going to be sent to the server every 20 seconds. I think that's the configuration. Here actually shows the last 6 hours of status logs. You can just configure this the way you want. But I mean, 6 hours should be fine. The thing is that, for example, the settings for this is logging locally. So this is all stored in Postgres. If you're going to be a lot of data coming into to this database, you will have some issues with your backend. So it's better if you actually configure osctrl to send the log somewhere else. Let's say Splunk, Kinesis, or Elk, Kafka, anything else, because otherwise that's going to be actually creating some trouble in your database. Or if you have good DBAs, then they can help you with that. Anyway, we've seen on-demand queries. Oh yeah, let's for example, let's do something with Debian. Like, so we are in this home. Let's create a file here. Let's say, okay, NCN demo file. NoConName 2020. There you go. So we do that, and then this is a home vagrant. So let's say that we want to extract that file actually. So let's say, okay. So we say, right, we want to actually extract that from the Debian file, on the Debian machine, sorry. And then the file is home/vagrant/NCN demo file, because that's the actual file that we want to extract. Actually, this is, well, I'm going to show you actually, we're going to run this for all the machines. So let's see, okay, let's carve this file. So now we configured osquery to be like, well, not osquery, oscontrol to say, okay, send this on-demand query to all the hosts to actually extract that file from that specific host. Not for all the hosts, because in this case, we targeted to the Debian 9. And then, okay, it got carved. Now this is the actual file, the block size and everything. Yep, the file is, we just saw it here. This is the file. There you go. That's the demo file. Oh yeah, it's we can actually show it here. Yeah, it actually gets started by default. Our files, NCN, there you go. Boom. That's the actual file that we created. And what happens if you actually want to say, okay, I actually want to carve all the files of all the environment NCN, and I want to extract the etc password, because I know they are Linux and they know that file exists. So like, okay, you can actually do that. You can say, yeah, I want to actually get that. Then there you go. That is actually, that file got created, got extracted from all the machines, and then you can see these are actually is shown per machine. So you can basically see, okay, you will actually see the etc password for all these machines. Like, let's see, for this one in this case is Ubuntu 14, and then yeah, that's basically the password file. And then let's take a look at it. Yep, there you go. That's the password file. So yeah, that's a very easy way to just extract files from machines. So I've shown you the different environments, how it works. I show you how to actually configure things, how to add new queries to the schedule, how to enroll nodes. And I haven't shown you a little bit of, I want to show you actually a little bit of the settings. So for example, now that we have a way, let's show this something. Let's go into this system. So we are going to be showing a little bit of the settings for logging. So let's go to Bacon. Let's make logs TLS. So now we're going to be looking a bit of the debugging, right? So, okay, we'll just flip the switch for debugging on, and we are going to be seeing for the different environments, we're going to see, okay, I want to actually see what's happening on the, actually, yeah, this is what I want. I want to the debug on for the admin server. So in that, because then I can actually see what's happening behind the scenes. Like, let's say, for example, that you have a machine that is, you have an environment that is causing some trouble because you're going to be, you want to debug some like bad data that is coming from your machines. And let's say, okay, how do I actually do that? How do I be able to say, okay, I want to actually see the debug logs from the one environment. So let's say, okay, in that case, you enable the debug HTTP, and I think we set the settings to be what is the value that we actually put the settings for? We did refresh in 20 seconds. Okay, so in 20 seconds we should be able to see that refresh. Yeah, that's 20 seconds going to take. So we're going to see that in. We just flipped the switch on that. So we are going to be seeing all that, like all the HTTP actually debugging. We're going to see it in the we enable debug service for TLS, and then we have also the debug for NCN. We are going to see all this information be flowing the logs as soon as that setting is applied, which should take too long. 12:15. Okay, let's see. HTTP debug. Yeah. Okay. Let me see this. Thing is, I'm gonna do admin because we probably saw. Yeah. There you go. Here we saw that we flipped the switch for the settings, and then we see that things are happening inside of the oscontrol admin, which is the one that, for example, in this case, like, let's say, okay, I'm gonna remove this off. There you go. Now we have enabled, this is for admin because we enabled the admin on off and flip this on, because otherwise, yeah, there you go. That's too much actually data, but that's basically what we're gonna be seeing in TLS. Something is wrong here. Oh, I think I know what is going on. TLS settings. I didn't change this, I don't think. Did I? Save. Oh, I think I know. Yeah. Didn't change this. Okay, so well, these settings, for example, are the ones that are for when all that makes any change to the admin UI. For example, the queries, the link for all the queries that we've seen, or there you go. Yeah, here. So it wasn't not like picking it up. Yeah, it took 5 minutes. I think that setting is off. Anyway, yeah, like for example, if here you see all the actual the discussion, the points that we've gone through on the different handlers for the TLS endpoint. This is actually the traffic. See, you recognize the request or the format of what we discussed. Like there you go. This is the node key for config, just sending the node key, and this is the configuration that is responded from the server. So with the actual HTTP, you can see that happening in real time, quasi real time. So yeah, that's something I actually wanted to show, how actually you can debug your osquery clients. So yeah, I think the demo is pretty much done. Yeah, well, let's actually do something else. I want to actually show you something. Let's create a user. Like last time, one of the things that I actually enjoyed implementing was the RBAC permissions cross query. So for example, username is going to be NCN. Let's see, for example, we say, okay, I want a user that has access to the last environment that we created, but not to the let's see, like this test user shouldn't see any of the NCN, right? So yes, it only should see dev. So we don't have to do this test for NCN. No admin level, no creation of the API token. So we create this user, and then this is the test user. We are going to be here the permissions. So let's say, okay, let's actually give this user access to dev, but like let's see, it cannot be running queries or car files. And then we close here. We can just log out. Oh shit! I didn't set the key, the password. My bad. Move it and then create a new one. I forgot. Username test, password test, test for NCN. No admin level. Adding it. Let's give it access to the dev environment, but that's about it. No queries. Now we can log out, and we can be like, okay, test. And now you can see how it doesn't have it because this actually is it's all empty, but it should that's actually a bug. Okay, that's good to know. Anyway, you see that it doesn't have actually the ability to run queries. But if we actually because if it's not an admin, it won't be able to see the settings. But let's grant access to admin. Yeah, let's grant access to actually to run queries to that user. Yeah, run queries. Boom. No carbon files. Now worked. Log out, and then let's test. Test. There you go. Now that can run queries in environment dev. Yeah, the other one shouldn't see it. It's a sexual bug. I'm gonna open that issue anyway. So I think that's it. Like that's the demo is pretty much over. Yeah, we go. That's dev, and then this is the other one. Cool. I think that's pretty much it. Let's see what else. Yeah. Things that I want to actually do in oscontrol. Well, I want more functionality for oscontrol API. I forgot to show you guys one thing, which is actually show it because it's kind of cool. You go to oscontrol. That is when the installation goes. And I want to actually show you the CLI, which actually use the backend connection. So the CLI is if you don't want to if you want to automate something for scripts, then the CLI is very handy. Let's say, for example, okay, I want to see the users of the system. All right, I want to see list. Yeah. So let's see. Yeah, that's pretty much the users. And let's say I want to delete the user. Let's for example here. Where is it? Here. So let's see that we have users. Let's look at the users. Okay, so we have here the users. So let's just create. What was the thing? Delete. Oh, I think I provide the username. Yeah. what's the actual format? -u test. There you go. That happened. Yeah, there you go. I deleted the user. And you can actually see the nodes. Node list. Yeah, you can see the nodes that are actually enrolled in all the environments. So here is the here you can manage this from the command line interface basically. But yeah, I just wanted to show you the guys as the last thing. Anyway, where's the presentation? Here. Yeah. Okay. Yeah. Future things that I want to put more functionality to API. I didn't show much API, but that actually would take a full workshop. Yeah, I want to implement more things in API. I want to actually implement more things for the osctrl CLI. I want to implement query packs, dashboards, graphics, things that are very nice to show what is the health of your machines. And yeah, I have tags as well, more functionality in tags. There is one thing that I want to work on, which is the backend usage. Do a bit of profiling to make sure that there is like proper, not the spikes in CPU. And yeah, if you actually look at the issues list or you have any issue, just create it there. Like the issues are a good way to understand what is how is the project going and what is the direction to go. So, well, after the demo, kind of long demo. I think it took me a bit because I forgot to actually build the osctrl server. But anyway, conclusions that I want to actually finish off with for this presentation. It's many often, for security, buying a solution for a problem, it's better than building your own solution because sometimes you have like a solution right immediately. Sometimes building the solution. I mean, whether you are going to build a solution or buy a solution, you are always going to spend money. Whether if that's actually to pay for that solution or for the engineering effort that it requires to build a solution. So that's something that even for open source solutions, there's still that spend that you will have to do. In terms of scaling a TLS endpoint, always plan for the worst case scenario. It will never, you will always, something always will go bad. And then, that's kind of like, it's going to be the best learning experience. But yeah, if you're going to have an incident to learn how a part of your infrastructure works, then it's not that great. I haven't discussed much what is to actually deploy one of these TLS endpoints in the clouds or one of the clouds. But if you're going to be using the clouds, just make the most of them. Very often, whether if it's AWS, Azure, or GCP, they offer you the ability to use like Elastic instances, things that can scale based on needs. Those things are always, they will have a cost associated. But if it's critical for the business, then you want to kind of like make the most of it. So yeah, that's a good kind of like lesson. But we've seen how to extract the logs and how to actually collect them. Once you have logs, don't forget about them. Those logs are actually going to take space, and if you're going to be taking paying for that storage, use that information for something. And if you are not using that information, then don't collect it. Like, I don't know, it's just a waste of resources. Obviously, this is a very generic approach to this because it's if you're going to be using detection infrastructure for being able to tell what is the status of a specific system at a given time, then yeah, that historic of logs is going to be useful anyway. If in the case of an incident or something, but it's good to remember that those logs are collected somewhere. And the last thing I want to always mention is that in terms of open source, always read the code for hidden or undocumented features, because usually that there is really good value that is in those in those undocumented features, and you can use that for a lot of things. So yeah, after that, if you have any questions, then I'm happy to answer.